If you got to this video, then you're probably like me. You started Angular not too long ago, built some things, but then you wanted to unit test. It sounds easy, but then you go into the documents and nothing really makes too much sense. You get through it, but you really don't understand what you're doing. I'm going to give you the training I wish I had when I started doing Angular testing. First things first, you need to have Node installed in the Angular CLI. There's not too much to it. Run npm install g Angular CLI. If you have the wrong version of Node, it'll tell you to upgrade. And once you've got that installed, we're ready to continue. If you haven't had a chance to, go ahead and build an app or run the Tour of Heroes, because this will make a lot more sense if you understand how Angular works first. So in the Angular test documents, there's a whole lot of information, but I read this whole thing and it didn't make much sense. What I missed was this sample application right here. I have a link to it down in the description so you guys don't have to come find it here, but that's what we're going to be messing with today. So once you download this, start with npm install, and that can take who knows how long. And once the npm install finishes, we're going to run the npm build from this folder. We're just going to run build to make sure that everything's working correctly with Angular, and if ng build doesn't work, we're not going to even try jumping into testing. Okay, our ng build's successful, so let's move on to ng test. So by default, if you build your app with the Angular CLI, it'll automatically build in this testing for you with ng test, these command lines, and here it'll kick up the HTML test reporter for Karma. So Karma is a test runner, and Jasmine is kind of the language that we're writing our tests in. If we take a quick look, we can see that Karma is the Angular test runner. This is a lot like other test runners that exist for JavaScript. Jest is another example. And then there's the Jasmine behavior-driven JavaScript language. And you can come out here to find more information about Jasmine. But basically, it gives us this describe and it syntax, and I'll talk about that more in just a second. So pulling up this project that we downloaded, you can see that it's just a standard Angular project. We have our source, we have an app, and then the TypeScript that is running in the tests is basically side by side with the component. So we have Twain component spec.ts, and we have Twain component TS. So the component is basically the JavaScript that's behind the application we see, and then the spec is the test for those. So if we scroll up to the top, we can see a lot of stuff here. But let's take a step back and maybe let's just serve this page to see what it is. So I'm just going to run ng serve so that we can see this application first. So here the app is now served, and we can see that it's the Tour of Heroes test app. If you ran this, then you already know everything about this. If you've never run it before, basically we have this dashboard with the top 4 heroes. We can click into a hero here. We can go back. We can go to the Heroes tab and see a list of all these heroes. We can edit heroes. If you click save, and then it comes back and it's edited, and then there's this about page. And here's this quote of the day. And this is going to be that Twain service that we were seeing. There's some other elements up here. But basically, this is the app that we're going to be testing with and demoing testing with. So I'm just going to close this and rerun ng test. And while that's starting up, let's go ahead and start talking about what is going on here in these tests. By default, Angular has a standard saying that the JavaScript goes side by side with the component you're testing. And this is mostly because that in the likelihood that this will move, everything moves together, so you don't have to re-import and fix everything because it's relative to being right next to it. So we're testing the Twain service. That was kind of that top quote from Mark Twain that we're going to take a look at. That's probably the big one that we'll look at because it's got everything we need to build a unit test. I just want to show that there is another testing folder here. And these are other tests that kind of go along with everything in the app, so that they've kind of got some helper stuff sitting out here in this testing folder. If you want to look at it, you can go ahead, but none of it's necessary to actually test your own stuff. So in this component spec, we have imports at the top, and some of these are from Angular core testing, and we're going to get into a couple of these here. The big one here is this test bed. So down here, we can see this describe, which I said before was from Jasmine. And then we've got this before each, which happens inside of a describe. But if we actually collapse these down, we can see that there's another nested describe inside of this describe, which kind of builds the sentence that says Twain component when test with synchronous observable. And if we come back over to our tests, we can see Twain component when test with synchronous observable and when test with asynchronous observable. So depending on which ones you're looking at, you can see basically which grouping of tests is under this describe. And it builds this sentence with these it blocks. It's a weird syntax to put a test under, but when you think about it, when test is synchronous, it should do something. So that it is describing a behavior that your program it should do. So that's kind of how I think it makes sense. But basically, each it is a test, and each describe is kind of a block with its own before each and after each. Inside this before each, there's kind of a lot of stuff going on. They have this error message that's here. They have some stuff that they're going to be using in all the tests. So they kind of declare it all here at the top of the describe. And then in each before each, they're setting all of these components up. To start out, they have some test data here. And then they're building a Twain service, and then they're using this Jasmine create spy object. So what this is, if you've used any other test frameworks before, is this is actually a mock. And what they're doing is telling Jasmine to mock the Twain service, and then also the function call of getting a quote. So here, when you go to Twain service, get quote, and return value of test value, they're saying basically when the Twain service mock calls get quote and returns the value, it returns this test quote value, which is cool, but now we have to inject it into our actual Twain component because the Twain service dependency injects this. So here we can see providers, we can see declarations, and we can see this test bed. But what's a test bed? If we come down to the app module, we can see ng module. And inside ng module, you have imports, providers, and declarations. What that test bed is basically a test version of ng module, which handles imports, providers, and declarations. It also has bootstrap and a couple other ones, but you might not see those very often in your tests. So that now we can declare basically our test ng module config here. The declaration, this is usually the component that you're testing. Providers, this is anything that's dependency injected here. So if we come look at the constructor, we have a Twain service here. So that needs to be provided so that we can build that up. So here we want to provide a Twain service and use the value of the Twain service that we've built up with the spy. And that's really confusing when you start out with. What you can actually do, if you just want to use the real value, you can just use the Twain service that's there, but then this will make actual function calls out to an API, and you probably don't want that. That gets really strange with your testing, especially if your service goes down. So this is how you provide a different mock implementation and not the actual live service. After that, we have a fixture here, and that does create component. Here, basically, this create component uses this test thing, and it basically does an initialize on a component, and then you can use the fixture to grab an instance of your specific component, or you can use that fixture to grab elements on the screen. So here we're grabbing the selector of class Twain to grab the quote that's on the screen. So the way Jasmine works is we do this first before each, we set up our mock, we grab our fixture, and then we go inside the next describe, and this describe isn't doing its own setup, so we're going to follow along and go into the first test. And here you can see we have an expect with a 2b. So here it's expecting this quotes, this class with Twain, to have a text content that has nothing. But when we go look at the app in the tour of heroes, it has a quote. So don't we want to have a quote? Because it doesn't make any sense that we would test it with nothing, does it? Because we even said here that it should have test quote. Well, there's actually more going on here that you're not seeing, because here you can see when we do an expect spies calls any that the quote isn't even called yet. But why is that? These test beds fixtures actually have a life cycle that starts with detect changes. So if you look at detect changes here, it says that it triggers a change detection cycle for the component. So basically that's your on init event going on right here. So you can get this fixture, but it hasn't been initialized and drawn anything yet until you run detect changes. So then here we can check in this test that this quote text content equals the test quote that we assigned it to originally, and it'll actually work. And we can also see on our spy that it's actually been called. This test isn't super useful. You'll probably not write too many of these. Otherwise, you're probably going to want this test to be more often the test you run, because you want to detect the changes on your fixture and then make sure the value that you want to be set there gets wired up and set to the correct area. Down here farther, there's one other thing I want to be aware of, because not only can you detect changes, you can also run a tick, and a tick simulates an asynchronous passage of time. So basically, if you have any other things going on the screen, like timers or waits or anything, tick's what you need to basically flush out all those set timeouts. So if you have something that you're expecting to happen on the screen after 300 milliseconds or something, you have to run the tick event and Angular will go ahead and flush out any of those waits to make sure that your event actually happens. So we can see here they're throwing an error, they're detecting changes, and then the spy errors after, and they have to run the tick to flush everything and then rerun the detect changes. That's all cool. We have all our tests, we have a whole bunch of them working, but there's one other thing in here that I haven't talked about, and that's this with context. And this is just kind of a helper to give you some help text if this test ever fails, because right now you'll not see this nothing displayed. But if I go and put some garbage in here and go ahead and save it, ng-test will automatically rerun the tests because it's got a watcher on these files, and then here it says nothing displayed, expected nothing to be an A. So this is where you can kind of set what your expectation is, and then it'll throw out on your test report that nothing is displayed. This is your test context right here, and then it'll say what the expectation was when you listed it. It's not required, but it could be nice. The stack trace isn't super helpful at all, so anytime you can give yourself some kind of context around what your test would be, it's going to be better for you in the long run, especially if you have 5, 10, 15 tests fail. Anytime you can make this easier, it's going to save you a lot of time and effort. So all I'm going to do is fix this one here, save it. Karma will go rerun all the tests. We have our 205 passing tests. Once you understand how that test fixture works, once you start understanding how to inject things into the test bed, there isn't too much new stuff that you would need to check out, but you can come in here and see lots of examples. They do have some samples in here of using the test bed and not using the test bed. So here's the hero detail component, no test bed. So if we go just check that out here, hero detail component, we've got 3 different ones. We have the no test bed, and we have the spec for with the test bed. And then we also have our actual component here. So it doesn't really change how you build your component. You can see here they're injecting hero detail service, activated route, and router. If we come back over here, you can see with the testbed, it looks almost exactly like what we did before. They have declarations. You do have to declare your pipes here in declarations. They have imports. This is, I believe, the form module that is being used to highlight forms on the screen. And then the providers here to use the mock values and mock spies that they have. So that's the testbed way to do it. If we come over here, there's another way to do it without the testbed, and I'll let you study this more on your own. But basically, in your before each, you just build everything up. You build an activated route stub. You still build your mock. After you build your mock, you build your hero component just by passing everything in. You grab a reference for it, and you do the on ng init. So this can be cleaner if your team likes it more, but also the testbed also makes it easy with dependency injection. So if things change in the future, it's easier to sub it out and not have to go recreate everything in this list. Use whatever you're comfortable with, but the main gift here is that you now have a list of tests where if you want to find something, for example, if I wanted to look for routing or even like the HTTP client testing, I have a list of tests right here that I can go to and search for in this app and see what's going on. There's things grabbing H1, H2s, no title on the DOM, and there's also ones for like routing. So if I come down here, you can see that I can grab router links in the template. I can tell the router has navigated, and I can test a whole bunch of other things on services and router links that I wouldn't know how to do otherwise. If you ever want to move on to end-to-end testing, you can check out my video on Playwright, which is a great end-to-end testing framework for every app, not just Angular.